This section is called multiplying rational expressions. The example is 2a plus 2 over 3a minus 3a squared. And all of that, I multiply 3a squared minus a minus 2 on top, and 9a squared minus 4 on bottom. So I need to simplify each of those 4 different equations first. Let's start over here on the top. Is there a term I can pull out of both of those? Yes, the 2. So if I pull the 2 out, that turns into a 2a plus 1. And then on the bottom, I can pull out a 3a. So 3a times 1 minus a. So there's my first fraction simplified. Then my second fraction, so let's start on the top. The factors of 3 are 1 and 3. So I need a 3a and an a. Then factors of 2 are 1 and 2. So I need to put these in the right combination so I end up with a negative 1a left over. If I do the 2 here and the 1 there, that will give me 3a squared, a 3a, and a 2a. So I want my 2a to be the positive and my 3a to be the negative. Then I'll end up with a negative 2 at the end. Okay, down on our bottom, we don't have a term that we can pull out there. We just need to factor it. Remember, we're trying to get things to cancel. So let's do a 3a and a 3a here. That will give me the 9a squared plus 2 minus 2. Then my middle terms cancel out, and I'll have a negative 4 at the end. So now, rules for canceling here. Same as before. I can cancel straight up and down from each other or diagonally across the equation. So my 3a2 over my 3a2, those will cancel out. Now, I have an a minus 1 over here that should be able to do something with this 1 minus a over here. But I probably want to rewrite that first so that I can make sure I'm doing this correctly. So I have 2 times a plus 1. And then if I rewrite this, I would have a negative a plus 1. So if I pull the negative out of that and make this a negative 3a, that will turn into an a minus 1 right there. And then over here, I had an a minus 1 over 3a minus 2. Okay. Now my a minus 1s can cancel out. So a minus 1, a minus 1. Then my final answer, I'll have 2 times a plus 1 on top. My other top terms are all gone. Then I'm going to have negative 3a times 3a minus 2 for my bottom term. And remember, it doesn't matter if my negative is on the top term, on the bottom term, or right in the middle. They all mean the same thing. So there's my final answer. But if you look at the way they worked it here in the book, they skipped the step where we rewrote this part of the equation. So they skipped and went directly to reducing a minus 1 over 1 minus a into a negative 1. If you're comfortable with doing it that way, that's fine. I find it easier to remember what I'm up to if I write out the steps. Then I don't end up leaving off the negative somewhere. Let's go back to the homework. Multiplying fractions. So 18 b squared plus a 5b minus 24 on top over b squared minus 6b plus 9 on bottom. There's our first term. And all of that multiplied by b over b squared minus 64. Okay. So I need to simplify each line. Let's start over here on this top line. So factors of b squared have to be b and b. And then factors of 24, I want to end up with a 5b. So 2 and 12 are a likely combination. 1 and 24. What else? What are the other factors of 24? 3 and 8. 4 and 6. Okay. Let's try 3 and 8. Those are the most likely to get me to 5. So where do I want my positive? Where do I want my negative? Remember, my 5b is positive, so my bigger number needs to be the positive. My smaller number is the negative. So b squared plus 8b minus 3b, so there's my positive 5b. Negative 3 times 8, negative 24. Okay, bottom line, b times b. Then factors of 9, let's use 3 and 3. I want to end up with negative 6b, so they both need to be negative. And I'll still get my positive 9. Okay, second set. So b cannot be simplified any farther. So perfect square, b and b, 8 and 8. So if you are stumped, let's figure out how to simplify. Check back in the rest of your problem, right? You're trying to get terms in common that will cancel. So I had a b plus 8 over here. So likely, b plus 8, they will cancel. I have a b minus 3 and a b minus 3. So what am I left with? The final answer is b on top all alone, and then b minus 3 times b minus 8 on bottom. So there's my simplified version. 20 6v squared plus 23v. Not a fan of this marker. I couldn't tell. 23v. We'll just start on 20. Six v squared plus 23v plus 21. So there's our top term. And I have 4v squared minus 4v minus 15. Those are all multiplied by 4v squared minus 25 on top and 3v plus 7 on bottom. So I know to cancel that 3v plus 7, I need to end up with another term that looks like that somewhere. Let's work each line here. The second fraction looks a little bit simpler, so let's start over there. So 3v plus 7 is as simple as it goes. Then 4v squared minus 25. There's some perfect squares to work with. We'll have 2v plus 5, 2v minus 5. Right. So there's my 4v squared, my middle terms I'll cancel, minus 25. So I need to end up with something that looks similar to that to get them to cancel. Go back over here. Factors of 6 are 1 and 6 and 2 and 3. So let's try the 2 and the 3 combinations. 3v plus 7 is what I want to be able to cancel. Is there a way that I can make that work here? The factors of 21, 3 and 7. So if I do a 3v plus 7 and a 3v plus 7 in my first set of brackets, can I make that work? So I would have 3v times 2v, there's my 6v squared. If I have a 7 here and a 3 here, that will give me plus 14v plus 9v. So there's my 23v and my plus 21. Okay. Down on the bottom, same thing. If I want to cancel a 2v and a 5, then those probably need to be terms I work with over here. So I have 2v times 2v, so there's my 4v squared. Factors of 15, I want to use the 3 and the 5. Negative 15, so one of my numbers needs to be a negative and one needs to be a positive. How am I going to end up with a negative 4v? So I've got 6v squared, 6v, and 10v. So my 10v needs to be the negative, and my 6v needs to be the positive. So I end up with negative 4v. Now let's cancel terms. 3v plus 7, 3v plus 7. 2v plus 3 and 2v plus 3. 2v minus 5, 2v minus 5. Remember, these all cancel to 1s. So I end up with 2v plus 5 over 1, or 2v plus 5. Remember, everything written over 1 is itself.